Kirk Math. Hello and welcome. We are here on Module 6.3, Ratio Tables. So we're going to review really quickly. Well, not review, but we're going to learn how to use a ratio table to find equivalent ratios and solve problems. So we've been learning a lot about ratios and rates recently. And we've been learning lots of different tips and tricks and ways to solve problems. Ratio tables are just another way to solve a problem. So we're going to learn in this lesson just kind of what a ratio table is, what its parts are, and how to fill it in and answer questions about with it. So the very beginning, we are going to add some notes here. So it says that a ratio table is a way to compare quantities. So all ratios help us compare quantities. Ratio tables in particular help us compare them really well. So in this example, we have Todd earns $3 for every 5 chores he completes on his chore chart. We're going to find equivalent ratios using the ratio table below. So in order to fill in a ratio table, you take the information that is given and we are going to fill it into our table. So we have chores on the left, so that's going to be 5 and $3 on the right for our total. And then to fill in our ratios as we work our way down, we're basically going to skip count by 5s in our chores and skip count by 3s in our total. Because I'm basically adding groups of these ratios. So right now I have one group of 3 to 5 or 5 to 3. And now I'm going to have another group of 5 to 3, which would make it 10 to 6. And then I'll have another group of 5 to 3, right? So we're just kind of adding these groups together over and over again. So I'm skip counting by 5s here, 5, 10, 15, 20, 25. And then on the right, I'm skip counting by 3s, 3, 6, 9, 12, 15. Okay. Over on this side, we are going to write our ratio of chores to total. So our ratio is 5 to 3, 10 to 6, 15 to 9, 20, 12, 25 to 15. And you might be thinking right now, like, this is really easy. What is even going on? So that's why we're going to start analyzing this table and really make sure we understand how it works, okay? So the first question says, how are the number of chores and the amount of money related? Okay, I want to know how this column and this column are related to each other. So it's going to be more straightforward than you think. Basically, for every 5 chores, Todd, let's make his name capital because he's important. Todd earns $3. So for every group of 5 chores, he's going to go earn $3. That's why we skip count it. All right, how are the values in the chores column related? Well, we already said that we skip counted by 5, but to make it more mathematical, we are increasing the value by 5. So the chores is increasing by 5, and the values in the total column are increasing by 3. And then we're going to look at this ratio column. So we're going to ask ourselves, what do we notice about the ratio column? And what you should notice is that each of these ratios that we wrote out are equivalent. Equivalent and equal to 5 to 3. Basically, they can all be simplified to the same ratio. And that ratio is 5 to 3, which means that all of these are equivalent. And this is just the basics of a ratio table. So let's try some more practice here. So now we have Mr. Baker. He's making pancakes and reads the recipe on the back of the pancake box. Use the information in the table to determine the ratio of cups of pancake mix to cups of water. So here we have our table. Cups of pancake mix across the top and cups of water across the bottom. First, we're asking ourselves, what is the constant ratio? So we're basically asking ourselves, what is the thing that we're skip counting by? What are we constantly moving up by, right? So this top part, cups of pancakes, is increasing by 1 consistently. We're always increasing by 1. This bottom part of my table is increasing by 1.5. We are always adding 1.5. So our constant ratio is 1 to 1.5. 1 cup of mix to 1.5 cups of water. Our constant ratio can also be found right here in this first box. It's the most simplified part of our ratio, or our most simplified ratio. All right, the next part asks, how many cups of pancake mix will be needed if there are 15 cups of water? Now, there are 2 different ways to do this. We can extend our table and continue skip counting by those 2 different amounts, by 1 on top and 1.5 on the bottom, until we get to 15. 7, 8, 9, 10. It's going to take us a while. We could, so then this would be 10.5 plus, right? Because we're adding 1.5 each time. So if I add 1.5, that's 12, 13.5, 15. That is way 1. So we can see here, if I have 15 cups of water, I'm going to have 10 cups of mix. So one of the ways we could solve this problem is by extending the table. Another way that we could do this is we could bring out the old equivalent ratios, like we've been learning before. You could do the 1.5 and the 1, or you could take a more easy to use ratio, putting 15 in where the water is, and you're keeping the other one blank for pancake mix, and then using that multiplication to solve like we've done in the past. Times 5 times 5, that's another way to do it. I have also had students use the table to kind of not extending it, but adding until they get to 15. So they could say, well, 5 cups of pancake, oh no, sorry, we're doing cups of water. I was doing cups of pancake mix. Hold on. Whoops. We need to make 15 cups of water. Okay, we could do 6 cups of water plus 6 cups of water makes 12, 13, 14, 15, and then add the 3 cups of water. So that would kind of look like this, is they would have a 4:6 ratio plus another 4:6 ratio plus a 2:3 ratio. And that would make 15 on the bottom, and then 4 and 4 is 8 plus 2 is 10. So that is another way to get our answer. There's lots of different ways we've learned. You could have used your unit rate as well of 1 and 1.5. Okay, a couple more. We're going to complete the ratio tables and answer the questions. A cookie recipe calls for 3 eggs for every 2 dozen cookies. 3 eggs for every 2 DZ is dozen cookies. So I'm going to fill in my table. 3, 6, 9, 12, 2, 4, 6, 8. All right, so our first question is, how many cookies, sorry about that, how many cookies can be made with 12 eggs? Well, this one is in my table. I have 12 eggs already here, so I can identify my answer in my table. It's going to be 8 cookies. All right, in our next one, it says how many eggs are needed for 60 dozen cookies. Now I could extend my table, but 60 dozen, skip counting by twos, that's going to take forever. I would need a separate sheet of paper to do that. That is an option. The other thing that I could do is set up a bar equals bar model, knowing that 3 eggs makes 2 dozen, and I want 60 dozen. Then I can identify what I'm multiplying by and multiply by the same thing on top. So that's going to get me 90 eggs. Okay. Over here we have a developer who's selling apps. So I'm going to pause and fill in my table. You guys do the same thing. So a developer earns $6 for every 21 apps downloaded. So we filled in our table by skip counting by 21s on top and skip counting by 6s on the bottom. The first question says, how many apps will need to be downloaded in order to earn $84? So be careful because there is an 84 over here, but that is 84 apps. I want $84. So I would need to continue skip counting by 6s to fill in this table. Another option is to make that equivalent ratios, knowing that this is 21 and this is 6. This would be 84, and then solving using our math here. Okay. So you can see that I used some long division here to figure out that 6 goes into 84 14 times. Then I'm going to multiply 21 by 14, so I did that over here, and I got 294. So I need 294 apps to make $84. Now for this next one, we want to know how much money the developer will earn if there's 105 apps. Now if I do extend this table and I add another 21 to 84, I am going to get 105. So then all I need to do is add another 6 at the bottom here, and I'm going to get 30. I will get $30 if I make 105 apps, or if I download 105 apps. All right, in this problem here, it says the relationship between the number of babies to the number of nursery workers is shown below. So we have a table. What is the ratio of babies to nursery workers? How many nursery workers are required if there are 35 babies? And if 7 nursery workers are available, then what is the maximum number of babies that they can accept? So I want you to go ahead and try this one on your own, pause the video, and then come back and check in with me. Okay, so our first answer we found in our table, the ratio of babies to nursery workers is 5:2. The second answer we found by extending our table until we got to 35 babies, and we get 14 workers. And then the third answer was a little bit tricky because if we had 7 nursery workers, we would be between 6 and 8. So I needed to add just one more worker in order to figure out how many babies to get to 7. But if I add one worker, I need to figure out how many babies to add. So I divided my ratio. 5 babies divided by 2 people is about 2.5 babies per worker. However, we can't have half of a baby, so we're going to round down because nursery workers or daycare workers cannot be out of ratio, meaning they cannot have more babies than they are allowed to have. So having half more of a baby is not legal in their business, but having half less of a baby is. So that is why we're going to round down to half less and have about 2 babies per worker. So now, because I went up 1, I'm going to go up about 2, and that's going to give me 17 babies. That's the maximum number of babies that they could have if they have 7 nursery workers so that they are not out of compliance. All right. Our last problem here has Miss Halpert. She wrote the table on the board and asked her students to find the missing values. And we want to know who is correct, Aaron or Oscar. So pause the video. Figure out who's right, and then join me for the answer. In this case, Oscar is correct, and that is because if you look, we do not have a consistent ratio in this table, and if we do not have a consistent ratio, then we cannot skip count and add things in our table. So Oscar is correct that we need to find a unit rate because it's not consistent by dividing and then multiplying. All right, and that is it for our first thing of ratio tables. Join us next time to look at how we're going to compare ratio tables to solve problems. Bye.